This morning, we had one of the leading AI scientists join us for a special keynote. And that was, of course, Bernhard Schildkopf. But that's not enough, of course. We have another leading AI scientist, one of the most famous AI scientists in Europe and in the world, Professor Sami Haradin from the Technical University of Munich. Sami is director of the Munich School of Robotics and Machine Intelligence, and he holds the chair of Robotics and Systems Intelligence. He sits on so many committees, he's involved in so many programs. I honestly have no idea how he does it all. Last time we chatted over Zoom, I noticed that he was reading a technical paper, I think it was on robotics. It's just, he's one of the people I admire the most, and I'm very, very happy to have you here, Sami. We are looking forward to your keynote. Thank you very much.
Yeah, hello, Nabil. It's a great pleasure to be here today, and thank you so much for your kind words. I must say, I cannot say how much today. This was an exaggeration. There's so many people I admire, and I'm kind of very grateful to be here. So thanks for having me, and thanks for giving me the time to give you a little bit of insight into a topic that I brought today with me. So obviously not the only one, but many others as well. What I call the digitized presence in the era of intelligent robotic avatars. As you can imagine, many of the things I like to do is really about robotics, but it's about building intelligent machines that are able to learn, that are able to interact with humans. So just give me a very brief amount of time to just kind of introduce into the kind of ecosystem that I have the pleasure to be in, and our ministers of digitization. Judith Gerlach was just giving an amazing speech about Bayern, about its potential, about the things we're doing here. And it's a great pleasure to be in Munich and at the Technical University of Munich, which obviously is one of the really premier universities in Europe. And it's a great pleasure to have the honor to work with so many principal investigators at TUM MSRM, which is the Munich School of Robotics and Machine Intelligence, maybe one of the largest centers, also at extremely high quality of researchers I have the pleasure to work with. We are more than 50 PIs coming from all kinds of engineering, computer science backgrounds, natural sciences, social sciences, and so on, even up to the physics standpoint. So we're really trying to bridge the gap between the various disciplines that might be kind of related to AI and robotics. So experts from perception, from AI, but also from all the domain experts in mobility, health, and work, and others. So this is really the environment that I have the pleasure in working at. And in particular, what we're kind of pushing forward here in Munich at TUM, at MSRM, is really an integrative research center that bridges all the classical faculties, no purely focused research only on one domain. So cross-discipline is really what we want to push forward, coming from basic science, pushing the translation in this great ecosystem in Munich, together with the political decision makers, creating an ecosystem that really bridges the gap from basic research to translation, to startups, to industry, and really nurturing this amazing environment that we have here, which is, I think, really kind of unique in entire Europe. So MSRM itself is organized into two main pillars we call the innovation sectors and the research sectors. So the research spans really from AI, robotics, perceptions, the basic sense plan, act paradigm, you could argue, to the innovation sectors in health, work, mobility, and also more and more into the environmental aspects that we're kind of bridging. So what I think is extremely important is that we want to drive the real world impact, use-driven research. We target always for the famous sector of Pasteur, which probably many of you know, so really try to be cutting edge in the science and in the translation, so the impact to society, impact to human lives. Obviously, AI bridges all the various disciplines from deep learning, robotics, data science, control theory, and so on and so forth. But what is, I think, extremely important is that over the last 10 years, AI has really become a commodity technology that has not only reached our smartphones and maybe some kind of pure software-based solutions, but it really bridges into all our lives and more also giving value to the physical world in which we exist and in which we interact. So I think we will see more and more the AI factory, the next generation industrial revolution coming on demand, reconfigurable for manufacturing sites that really are able to produce at lot size one, but in particular are factory tools to the human expert, and really making it possible to bring humans and robots together, humans and AI systems on the most complex level, however usable to everybody, and really being as flexible as we want to see it to really kind of bridge to the next industrial manufacturing revolution. I think we all know that, and Judith Gellert just kind of announced also or talked about the health sector that is also very strong in Munich and Bavaria, where really the digital hospital, one could argue, is one of the grand challenges that I guess we all target for, especially in COVID-19 situations. This is something where we really want to kind of bring together the physical and the digital world together to be of best value to humans. So, but what does it mean? What am I talking about, all these digital physical things? I just want to give you kind of a very brief overview of where I believe that the future of AI is really lying. What's kind of the next things to come? And for this, it's really interesting to look at the kind of concept of the body. So in an AI without a body and disembodied AI, you could argue, and the one with a body. So what do I mean if I say disembodied AI? So an AI algorithm that basically takes via a data receiver and sender, computes the data, processes it, and then gives some feedback. We all know that from our kind of smart devices, Cortana, Alexa and others, that kind of take the speech signals, process them, and then give us the feedback in a sequential process, so really procedural computing. If we now come to the concept of embodied AI, so systems of intelligence with kind of a physical manifestation that is more than just an interface, then we come to the really complexity embodied AI problem, which is the things to come over the next years. So it's not all about data, but it's all about data and energy. So action via a sensory motor body with the environment and the reaction, data and energy. We might also call this the laws of physics as induced by these coupled interactions. And because there is an interactive process, so if I shake your hand, you shake my hand, it's kind of not a sequential process, obviously, then we obviously need to have algorithms, next generation AI algorithms that really understand physics, that understands the world we live in, that we interact in, and really are also coupled processes instead of purely sequential processes. I think this is kind of clear. And in the real world, this is really the way to go, and the next years to come that are really important to bridge there. I think it's kind of clear to give the analogy to the human body. So with our central nervous system, the motor control schemas we have. So we also have an interactive system that kind of senses and plans all the time, continuously. And the AI algorithms that are embodied into our system could be interpreted as a way of embodied AI system. So the difference mainly between disembodied and embodied AI together making up for AI is really this difference between sequential and fully coupled process, which, however, makes it so interesting because it kind of bridges to our real world again back. So to the digital, back from the digital to the physical world, cyber physical systems, embodied AI systems, namely robots. And why is this so interesting? And why did I kind of like to really work here in Munich is because it has a long-standing tradition in Munich. AI and robotics have done many of the basic breakthroughs were originating in Munich, which I could also see myself when I was still a student working with brilliant people here and really having lots of inspiration to come back here. So one of the first humanoids in Europe was developed at Technical University of Munich, bipedal, quite dynamic running, end of 90s, beginning of 2000s was a pretty big breakthrough back then. My own mentor, Professor Hirzinger, who was the mastermind behind the first robot in space in the beginning of 90s, one of the grand robotics pioneers in the world. So really brilliant people who brought and pushed forward this bridge between cyber and physical world and really pushing the edges in robotics and AI. Also, the first autonomous driving car has been developed in Munich at Universität der Bundeswehr, so the University of Armed Forces, by Professor Dickmanns, which was, I think, a very, very important step in the development of basic AI systems. And also in the recurrent neural networks community, Professor Schmidhuber and Hochreiter are one of the pioneers, or two of the pioneers who have developed LSTMs and really have pushed forward the boundary of deep neural networks for time series data learning and coding. And the latest addition, one could argue, is the next generation of robotics, tactile robots that are efficient in data usage, resource aware, machine intelligence, one could argue. So systems that really become a commodity for usage by humans. So humans operating these robots in a way that is natural, that is smart, that is easy to use, in a sense, one could say, tools for humans to make our lives better. So what we have been developing are robots with an embedded sense of touch, an artificial sense of touch that really is the basis to have physical intelligence in the real world. So robots that are able to have, together with a central nervous system, you could call it, obviously it's a pretty complex software system of algorithms that try to embed these human-inspired neural systems into the mechatronic robots and make them safe to interact, easy to handle, and really take them by the hand like a little child. And obviously equipped with a sense of touch to really be as safe as possible to interact with the physical world. This has led to real breakthroughs in industry, and more robot manufacturers in the world have kind of taken inspiration from our work all over the places in China, in US, and so on, to build robots that are collaborative, but also tactile, that have the sense of touch, and they can be programmed by a normal layman, by just technical people to use robots now like a commodity technology, like the hammer of tomorrow. It has become we could say the robot assistant with a sense of touch and easy to program interfaces. However, this obviously is still not a learning enabled system. So how do we get to robots that are kind of like my little daughter here, 4-year-old back then, learning in just a couple of minutes how to insert the key into the hole and running out of the door, out of home, because I was kind of telling her that if she's able to do this in less than 10 trials, she don't have to clean up at home the mess that she did. We did the same thing with robots. So we are now at the stage that we can actually replicate the learning abilities of motor control as humans in the stage of 4, 5, maybe 6-year-old kids. And robots are now finally, with a sense of touch and highly efficient machine learning algorithms that are aware of physics, able to learn not in hours or days and with huge computing infrastructures, but with only very tiny standard PCs to be able to learn as efficient as humans. And one of these systems is Garmi, which you can see next to me here, helping me with the presentation. So on the left side, I just want to show you what these novel type of physics-informed machine learning algorithms are able to give to robotics. So these basic motor control primitives that really are able to do similar tasks as humans can do. Our marvelous hand is kind of being mimicked. And if we compare that to standard deep reinforcement learning algorithms, so the standard in kind of deep learning, then we see that on the right side, the robot is simply not able to do this because it is not a number crunching problem. You need to embed into the machine learning algorithms the physics knowledge of how to interact with the world. And this is kind of the next generation of AI. So the cyber physical learning algorithms that really kind of understand the physical world in which the robots are acting, and leveraging that knowledge and really bringing engineering and computer science together. First order principles, data-driven algorithms, that really is the next level, because it accelerates, it's much energy efficient by orders of magnitude, and it's much faster than standard machine learning that we have seen so far. So there seems to be kind of new breakthroughs that will change tremendously the way that we will perceive these systems and use them, and really make them become commodity over the next years to come. This brings me also now to this kind of Bavarian view of things. It's really been a great pleasure to come to Munich after having been away for some years, and now seeing how the various politics have been driving, despite the corona crisis, the strategy that has been announced a bit more than a year ago, and really building this AI district Bayern about an AI network that Munich is the center of, obviously, as the international hub, with all the different players on site, which we all probably know. So from TUM, LMU, DLR, LRZ, Fraunhofer is here, and so on and so forth. Together with Helmholtz, we have very tight bounds. So there's really brilliant players around to not only have the basic science, but really bridge the gap to the innovation and technology, together with the marvelous industrial ecosystem that is at site here. So there has been an establishment of many new professorships. So there's really more and more excellent people coming to Munich, which is really important. So if you want to join a really brilliant crowd of people that are trying to push forward AI for society, then this is the place to be in Europe. So come here and really see for yourself. This is really where things are happening at the moment, and it's really a pleasure to be part of that. So just to show you all the different nodes and players in the AI network, and obviously there's many more coming, and the professorships are being filled at the moment, which is really a great pleasure to see that so many people want to come to Munich and Bayern in general. So there's lots of vibrant ecosystem where we kind of leverage all the different potential across the Freistaat, and really want to bridge towards becoming one network that really leverages the wisdom of the collective, you could say. Interestingly, also Bavaria has a very successful startup ecosystem. So especially in the embodied AI sector, industrial, healthcare applications, and so on and so forth. And what is, I think, kind of interesting, that this was just recently acknowledged also by Handelsblatt in the recent article, the Silicon Valley at ESA, about the deep tech technologies that are being developed here. We all know also, which is really wonderful for us as researchers, that the global players are coming here, as Google, IBM, Facebook, and so on and so forth, plus all the great German companies that are here, like Siemens and BMW and others, giving us really great potential to interact with the industry. We have been now established as an AI council that is now working together with the Bavarian ministries to drive that vibrant ecosystem, be of advice there, and really be a good voice, bring together the different stakeholders from research, from national labs, from industry together into this AI council, including also experts from ethics, from industrial sectors such as mobility, but also data, international companies, and other labs that work together, up to all the different universities in Munich, in Bavaria, which is really wonderful to see all these people working together and driving the ecosystem around. So what is the center of this Bavarian AI strategy? It's human-centered AI. So we really want to drive intelligent systems in whatever kind of application domains. Obviously, mobility, health, and work are of primary interest next to many other things like sustainability and trustworthiness being across sectors, relevant application technologies and kind of paradigms to be implemented. And it's extremely important to really have a use-driven perspective on things, and human-centered AI really bringing robots, smart machines, smart services to humans and really making their lives better and more livable is one of the grand goals and grand challenges we are facing in nowadays society. Anyways, I don't have to motivate that anymore. Many years ago, it was not so clear why this might be a great idea. And I think as of today, it's pretty clear that these kind of technologies can really change the way that we could even handle pandemics as of today. So we have been driving just to give you one of the kind of connection now to my actual title. So how can these systems be used in the future of health, robots for assisting elderly in the demographic change challenge? So this has been a video we did many years ago, just showing how we can in principle support humans via these robot systems, but not only as little helpers, service robots, but also, as you can see here, the real world implementations right now. So Garmi actually supporting elderly in carrying out certain tasks in everyday life scenarios, but also using this as telemedical systems to not only have remote interaction, audio-visual with the human, from the doctor to the patient, but actually use the robot as an avatar to basically bring the doctor to the human at site, to the patient, to obviously in Corona's times, this would be an absolutely safe interaction with the patient to do diagnostics, but also intervention, which is the great thing. If you have a remote body, a remote avatar, as you could call it. So you basically jump into the robot, you drive it around in the environment, and then you basically go to the patient, interacting with him, and then you could even do diagnostics, as you can see on this example. So the robot basically being your remote hand, your remote avatar, your remote body as the doctor to then deliver the diagnostics and treatment on site. So here we can see some very early prototype, how we basically teach these systems from remote. So this is virtual environments in which we kind of pre-train the robots and then actually deploy them in the real world facilities. So this is now really how we kind of bridge from human experts to the robots and make them really the remote body to bridge hundreds and thousands of kilometers of distance. We just recently did one experiment via standard internet between Bavaria and California, which is going to be published soon on this level. So here we can see the ego perspective. So the human sitting in the robot, basically being the robot, opening the door, and therefore having a remote body hundreds and thousands of kilometers at distance, and plus also feeling via the tactile sense, also the artificial sense of touch, what is going on the remote side, therefore bringing the safety of the human to the remote location and making these robots kind of being the tactile embodiment of the human. So we basically bridge not only audiovisual, but we bring via a doctor twin, you could say the doctor to the patient, then inhabit that body via the actual expert. And here we can see how this is being used in an auscultation scenario. So a patient being approached by the robot, but it is a doctor actually sitting in the robot, interfacing from his private practice to the robot at site. He's using one of these systems in order to kind of reflect the contact forces from the patient to the doctor so that the interaction is extremely safe and tactile sense of touch is being transformed. And as you can see here now, the auscultation is being done from a remote side, and also now you cannot hear the sound, but you can now really use state-of-the-art diagnostic tools to then basically do the right diagnostics. This has been kind of the core of our AI strategy here in Bavaria, I think, bringing technology to humans, human-centered systems that really are being appreciated by humans to really solve grand challenges of our societies. So this is really something that we want to push forward here. And if you want to kind of be part of that, and this is, I guess, really a wonderful opportunity to get this together. Last thing I wanted to show you, this is now something that we together with the university clinics are actually enabling also for remote corona testing, for all kinds of different things. We use these systems now to actually bring the doctor to the remote site and make essentially the doctor's abilities, expertise accessible to remote locations that obviously in our nowadays times are of imminent danger, not only to the patients, but also to the healthcare workers at site. Thank you very much for giving me the opportunity. It has been a great pleasure. Thanks.
Sami, my friend, that was great. That was an awesome presentation. So I'll take the time to ask one question, and it's about Isaac Asimov. As you know, AI will celebrate its 65th birthday in a couple of months. And Asimov is one of maybe of the intellectual fathers of robotics and artificial intelligence. What do you think? What are maybe the three main challenges that stand in the way of us having something resembling Daniel or Daniel, the protagonist, the smart robot, the detective that we've seen in many of his novels?
That's a great question. First of all, just as an anecdote, my dissertation was actually called Towards Safe Robots, Approaching Asimov's First Law. So I was really taking this first law of Asimov to absolutely ensure human safety from a scientific standpoint, kind of very, very seriously. And I think one of the kind of hurdles that has been there for many years and is now more and more kind of being removed has been the safety, especially in physical environments. Human safety has to be of primary concern. We see this in autonomous driving. We know this from drone technology. We know this obviously also from more and more service robots in medical technology. So especially if it comes to human interaction with these complex systems, we need to make sure that they are absolutely safe, that they are aware of what could hurt the human and really prevent that. So active prevention systems. This is, I think, a very important aspect from the technological side, but I have seen great progress over the last 10, 15 years. I think what is now really important is that we kind of also prepare the society to really embrace that technology, to understand how we can leverage this technology, how can they use it, educate people, make sure that Germany, I think this is especially important for Germany, gets again into this mode of embracing technology, embracing forward-looking kind of societal challenges we want to tackle with technology, and really make sure that we kind of have this innovation system running and also making people benefit from that by also bridging the technological bridging the technology towards real world environments, which involves certification, safety, but also really educating not only the youngest and the high potentials in the university, but really the broad society, which I think is a really key to the whole grand challenge of also benefiting in Europe, in Germany from AI.
Thank you very much, Sami. That was really great.